Hey there guys, this is Don from Prana-Tech. Today's video I'm going to be showing you my new TIG cooler that I made. I built this because I've been using an air-cooled torch for years and I've never had a water-cooled TIG. And I have a 250 amp TIG and I've been doing a lot more aluminum work over the last few years, and it's really, the air-cooled torch has really limited my ability to do long welds. I could do about 6 to 8 inches of weld before the torch got so hot that I couldn't really hold it anymore and I'd have to let it cool down. So it's one of the things I've been wanting for a while, but I wanted to build one big enough that down the road I went to a bigger TIG. It could handle that kind of capacity. So I'm planning on eventually doing a 300 to 350 amp TIG welder so that I can do much thicker aluminum. But right now I wanted to build a TIG cooler big enough that will last no matter what size TIG I get. So I built a large industrial size TIG cooler. I based it off of the designs you see out there from the bigger commercial TIG coolers. The smaller ones, there's a lot of them out there that are in the $300 to $400 range. There's even the cheapies on Amazon for around $200 to $250, and they're all right and they're fine for a small water-cooled torch. But I set my TIG up with a Miller torch so that I could weld a lot of heavy-duty aluminum projects, with thicker metal. And I didn't really want, to be on the edge of having enough. So that's the reason I built such a big TIG cooler, and I'll show you how I built it and how it works, and I'll go through all the systems so you can see, and if you want to build one yourself, you'll be able to see how it's done. All right, I'll show you the whole process, so let's get to it.
All right, so first I had to bend up both sides of the top and the bottom of the tank. And here I'm just welding in the bungs. That'll be the intake and the drain. And once I get those welded in, I started in on the cap, or the fill cap, and welded that in. And then I had a couple of other fittings that I needed to weld in on the top.
Alright, so once I got the tank sides bent up, I made some bungs for the fittings. I basically just took some aluminum stock that I had. It's probably 1.25 inches, and it already had about a little bit bigger than a 3/8 hole down the middle, so it makes it easier for drilling. So all I did was take slices of it off about 3/8 of an inch thick on my chop saw, and then I beveled the top edge. So you can see I've welded those in. I made 3 of them, one for the top for the bleed off. I've also welded them in on the bottom part of the tank. I've got one on that end, that's the drain, and then I did another one on the corner over here. That's going to be the feed to the pump. So I've got those done, but I want to tap everything and get it deburred on the inside before I weld the tank together. That way there's no chance of any chips being down inside of my tank. I want to have everything cleaned up before. I also went ahead and made a little motor mount because the pump motor is going to be mounted to the top of the tank. I just made a little offset standoff right here, threaded this bolts in from the bottom and Loctited them so that the motor can just sit down and I can just thread the nuts on without having to use 2 wrenches. And I just welded that on and on the sides and a little bit down on the ends too. Anyway, I've got the fill cap bung put in, and that's all welded, so I'm just tapping out the holes on the fittings here, and then as soon as I do that, I'm going to deburr everything and then weld the 2 halves of the tank together.
Alright, so I've got my sliding fixture that I made so that I could do long welds, and here you can see that I've got it set up so that I can do one of the long welds across the tank That way it makes it easy for my hand to glide along with the welder. This is a pretty handy setup when you have to do long welds instead of trying to slide your hand along your bench with the drag. It came out really nice. I'm pretty happy. This is the first big tank that I've done as a welding project, so that's one of the reasons I wanted to build this TIG cooler, is that I wanted to build it all out of aluminum. That way it'd give me even more welding experience, especially with longer welds.
Alright, so I've got the main tank welded up, as you saw previously. I welded all the seams, and now I've got all my fittings plumbed in for the pressure relief valve and the return and the feeder to the pump. I also went ahead and started building a frame. I'll show you that in a minute, for the tank to sit on, and that I can put sides and back faces on the cooler. So after I got the tank done, I went and welded on 4 tabs onto the bottom so that I can mount this to the frame. Here in a second I'll show you the frame. That way you can get a better idea of how this is going to go. Alright, so here's the frame I've made out of aluminum. This is made with some 1 by 1.5 inch C-channel that I had from previous projects, so I figured I'd use it since it was free and I already had paid for it. So what I've done is drilled and tapped the side frame for the tank so that I can sit in there. And then once I have the pump mounted and everything plumbed for the tank, with it all screwed together, I've got 2 computer copper radiators. I'm going to put them side by side, mounted on the back here, one on top of the other. One right there, and then another one right there above it. These are very quiet fans. That's the reason I picked them. I don't want this thing to be super loud. That's one of my complaints about a lot of the water coolers out there, is that they're very loud. And there's enough noise in the shop that I really don't want to have more. Alright, so I've got the frame pretty much finished, and I've got the tank remounted, and I built a little box mount for the 2 radiators on the back frame. I've got the plumbing for the return in and the loop going from one radiator to the next. This one will be the return from the torch. Now I just need to mount the pump and finish up the plumbing, and then I can build the sides and the top and the ends.
Here I'm just doing the final assembly and putting the plumbing together so that I can hook it up and do some test runs with it and start actually using it as a cooler, and making sure with test runs that it's going to work the way I think it's going to. And I've got the front panel made, and I just need to put the fittings in and hook it up so I can start testing.
Alright, so the TIG cooler has been up and running for a few weeks now. I've been using it, just working out the bugs. I had a couple leaks that I needed to fix with a couple of fittings that weren't as tight as they should have been. But other than that, it's been working great. I've got the top panel and the side panel off, and I'll show you what everything looks like inside, how I laid out the plumbing, so that you can see a detailed view of just how I did it. On the front, I used a 100-pound pressure gauge, and I've also got 2 quick change or quick fittings for the hot and cold. These are just standard TIG cooler fittings. They cost about, I think they're about $17 or $18 for a set on eBay or Amazon. The pressure gauge I did because the pump that I use will put out like 150 pounds, 140 to 150 pounds. So you have to be careful and not overpressure, because you can blow the lines. And so I didn't want to run more than about 35 to 40 pounds. So I needed a pressure gauge so that I could see, what poundage I was running the system at. And then I just have a lighted switch over here to the right for the on-off. If we go inside here, you can see that I just use the standard carbonator pump, and I use a Procon carbonator pump itself. The other is the carbonator motor. I used a Dayton. This is a standard Procon carbonator pump, and I basically set it up with a 4-way fitting on the output side of the pump, and just a 90-degree down to my tank right here. You can see I did it in a loop just to make sure I didn't have any tight bends, and it was easier to plumb that way. But on the outflow side, you'll see that one goes over to a sediment filter so that I can make sure that nothing clogs up my TIG torch. And I also have right here fitting, you can see come out to the left. This right here is just a push fitting, comes up to this hose. This just goes over to the pressure gauge so that I could see, what the pressure is running at. Out of the top here, you will see that I have another 90-degree fitting. This goes over to basically a precision needle valve. It's adjustable with a vernier scale. I think I paid for this on eBay. I think I paid like $17 or $18 for it. And what this does is, on the output side of the pump right here, as it's going to the filter, which is on the outflow side over there to the torch, this comes up and it's a bleed off valve. Basically, that I can bleed off pressure, and with this knob I can set it at a very precise setting so that I can dial in exactly what pressure I need for my output line. And all this does is go back to the tank. So it just basically bleeds off pressure from the outflow from the pump, and it's kind of like a pressure relief, but much more precise, because I can precisely set what my output pressure on my TIG torch is. Over here on the other side, you can see here's my filter. It's a simple filter that I got off Amazon. I think it was like $17 or $18. Comes out to an L fitting, and then another L, and this goes to the output side to the torch. Here's input coming back. Input comes back, goes to the bottom radiator, loops up through the center here, comes up to the input on the second radiator, flows upward, and then comes out to the outflow back to the tank. You can see that going down to the tank. I ended up putting a second bung in for the pressure relief flow, because the more I thought about it, I didn't really want the pressure relief flow going back into the tank into the same fitting. I was just going to put a T into that fitting right there, but I didn't want outflow from the radiators to be fighting against the bleed off pressure from the pump. So that is why I added a second bung to the tank and split these two up. This is the Dayton motor that I use. I'll see if I can zoom in so you can see the specs on it. Right there. It's a 1/3 horsepower motor, 115 volts, 6.5 amps, 1725 continuous duty RPM. This is actually made for this style pump. It has the spade type output flat shaft that fits right into the Procon pump. All I did was buy a clamp and put the Procon pump right on it. It bolts right up. It makes it a lot easier. On the sides here, you can see that this is just one of the side panels. I put some perforated aluminum. I basically just cut out a panel and I put one on either side. And I did it up here at the front because I wanted the airflow to be able to come in by the pump, because the pump has a fan to cool it as well. So on its way back to the radiators, the air can flow past the pump and the pump can get some fresh air to keep itself cool, because other than this is the only airflow into the case. And on this side, you can see that I brought in power through the back up to the switch. It's a lighted switch, so I did both hot and neutral. And then back out, I did the feed for the fans, the cooling fans, and the pump all on one, because the fans don't pull hardly any amps at all, and the pump only pulls 6.5 amps. So altogether, I bought a 15 amp switch up here, so I'm way below. I'm probably only pulling maybe 7 or 7.5 amps total at peak, which this pump doesn't run anywhere near peak because I'm bleeding off most of the pressure. So I would be surprised if it's running anywhere near the 6.5 amps. All right, so the fans all come on whenever you turn the switch on, and the motor comes on as well. On the back here, you can see that the whole back section here, where the radiator's output, I did the same perforated metal on the side there, or on the back I should say, and then just TIG welded it to an upper and bottom piece so that it was all one piece that just bolts on. Anyway, that's the view of it from the back. I'm going to put the side covers on and the top and the handle, and I'll show you what that looks like. All right, so I've got the panels back on and I'm ready to hook it up and show you how quiet it is. All right. As you can see, it's a very quiet cooler. That's one of the reasons I went with this pump and this motor, is that it's much quieter than a lot of the ones that have the integrated fan blowing on the back side of the motor. A lot of the Chinese coolers that you see that you can buy, they're even the Everlast is $400 to $500, and it has a big fan blade just bolted to the back of the pump motor. Well, I didn't really want that setup because they're a lot louder, and this is a lot quieter than the cooling fan on my TIG, which, you know, most of the time on a TIG this size it's not that loud, but it's loud enough, and I didn't want more noise in the shop. But as you can see, this one's very quiet. The only thing you can really hear is the motor running. The fans are so much quieter than the motor that you can't even discern them when this thing's turned on. All right, so I've been running this cooler for about 3.5 weeks, somewhere right in there. And I have to say I was very pleased with how it came out and its performance. All said and done, it probably cost me about, I'd say about $350. It might be $400 with all the fittings and everything else and the switches. But realistically, if it cost me $400, the Everlast cooler that they sell costs about $400. And it's loud, and it doesn't have anywhere near the capacity or the silence that this one has. This has a 3.5 gallon tank. Most of the cheaper ones have just a little, gallon to gallon and a half plastic tank. That is okay, and they're fine for what they're doing. But what I want is to build a TIG cooler that will last the rest of my life. I built this so it's compatible with just about any TIG out there. So if I get a bigger, like a Miller 350 amp, I can hook right up to this with no problem. In fact, that's the parts that I use. I have a Miller torch, and all of the parts that I use for the conversion to a water-cooled torch are all Miller. So someday, if I happen to buy, a 350 amp Miller, which I'm hoping, but then I'll still be able to use this cooler because it has the capacity to do as big a torch as I want. And that's what I wanted. I didn't want to build a small cooler and then later on go, I want a bigger TIG now, which I already knew I did. Now I have to either make a new cooler or buy a bigger one, which that's kind of a waste. So I'd much rather build an overkill one at the beginning, never have to worry about it again. And so here you can see why I have such a large TIG cooler. Anyway, that being said, I'm really happy with how it came out. It's performing amazing, and I have no regrets. The only thing that came out different than what I really wanted, I wanted it a little bit lower profile, but once I built the tank and the frame, it ended up being probably 3 or 4 inches taller than what I thought I was going to come out with. So no big deal. It's a little bit taller. Other than that, performance-wise, it works amazing. The motor doesn't get hot. The pump doesn't get hot. It's a great design, and basically all I did is copy one of the big name companies. A cooler this size from one of the bigger companies with a 3.5 gallon tank and this level size pump, they're about $1,400. So the way I look at it is, for about $350 to $400, I built a TIG cooler that is professional grade and saved myself $1,000. Granted, I have my time, but time is what I have plenty of. $1,400 for a cooler, that one's hard to justify right now because I'm not fabricating for a living. I'm building cool stuff that I like for myself. So anyway, that's about it for the TIG cooler. I hope you guys enjoyed the video and the build. If you have any questions, put them in the comments section. And if you like the content, subscribe. That'd be great. Hit the bell so that you get notified when I come out with new projects. And I appreciate you guys watching, and I'll see you on the next video. Thanks.